Okay, so I had you both go away, and I drew two graphs here. And so this is a challenge. And so now you can start to see, even with relatively straightforward pictures, that it might be pretty difficult to know whether two graphs are isomorphic.
Mm-hmm. Yeah.
And these, so first of all, do these pictures remind you of anything, or does any one of these pictures?
Well, this sort of reminds me of like the front face of a hypercube.
Okay.
I'm not sure about this one though.
All right.
Well, first thing, maybe we know that they're the same number of vertices. You can see that pretty easily.
Okay.
So we can count the number of lines if they're the same. 3, 4, 8, 9, 10, 11, 12 lines on that. We have 1, 2, 3 coming off of this one. 1, 2, 3, 4, 5, 6, 7, 9, 10. I think they're the same number, 11 and 12.
Okay.
So-
What's a different way you might be able to count those?
You can see there's 3 lines coming off of each point,
Okay.
but each line has 2 points on it. So it's 3 times 8 over 2, so 12.
All right. Good. Good counting. Okay. So we have the same number of points and the same number of lines. Is anything else the same?
Well, we have the same number of lines coming off of each point.
Ah. Okay.
Because each point has 3 lines coming off of it.
All right.
And here we have the same thing.
Okay. Nice.
So we should, in theory, be able to morph one into the other.
Okay.
So, how? So,
Like maybe we want to try to like untangle this. Kind of like we might move this over here and then move this one to there. Maybe try something like that.
Yeah, you know, what might be instead of drawing the pictures, I don't know if this will be harder or easier, but we'll just give it a try. Like, I'll label these as 1, 2, 3, 4, 5, 6, 7, and 8, and see if you can write in the labels over here and make them match up somehow. Maybe that would be a way to do it rather than having lots and lots of erasing.
so I think this one would be one up here because you can see this.
I think then it looks like that one's going to be 2.
Okay, how come? What made you think that could be?
So
two?
because this is the first line that comes off of this point.
Okay.
And the second line that comes off of this point is going to go down to this point.
All right.
So this.
That looks like it's going to be number 4.
So 4 goes here, and then you can see number 2 can connect to number 3. And then
Um,
off of number 1, another line coming down is to number 6. So number 6 will be here.
Okay.
And then number 6 connects to number 5. And then that leaves, so 6, and then 6 connects
well,
to...
if we're going off of the first orders of the lines, 6 goes to 1 is the first line on 6. Going up. Then I think that 6 going to 5 might be this line. Here, but I guess wait, no. Because 4 doesn't go to 5. So 6 going to 5 is not this line.
Okay.
So, then the other line, other line must be 7.
And 4 does indeed go to 7.
And then you have 8.
Okay. So let's check. So what points does 1 connect to over
So
here?
1 goes to 2,
2,
4, and 6.
Okay.
2, 4, 6.
All right. How about 2? What does 2
2
connect
connects to 1,
1,
3, and
5.
1, 3, and 5.
to? Okay, good.
3 connects to 2, 4, and 8. 2, 4, 8. 4 connects to 1, 3, 7. 1, 3, 7. 5 will connect to 2, 6, 8. 5, 2, 6, 8. 6 will connect to 1, 5, and 7. 5 to 7. 7 will connect to 4, 6, and 8. 4, 6, 8. And 8 will connect to 7, 5, and 3. 7, 5, 3.
Huh. Look at that. Can you see that connection now? Or is it still difficult to see even when we've got it labeled this way?
I think
It's
I can
still pretty difficult.
Yeah, it's actually still, because you're gonna have to do a lot of like untangling. You're gonna have to pull. Means these. You might think that this like sort of square will connect, but it's actually you can see 1, 2, 3, 4 of the outer square.
Ah. Very
Like
nice.
here with 7, 4, and 8, right? 7, 4, 6, 8 here. You have to pull 6 all the way like over here, but keep 4 and 8 where they are,
Uh-huh.
and then you have to move 7 in. So this is gonna look completely different.
Yeah. But yet, somehow these are the same.
Yep.
Somehow they're the same. Because we can label the points and show that everything connects to exactly the same way, and you've counted everything.
Yeah.
So it's cool. So the last thing I'm going to show you, and I won't include this in the video, is I'll show you the talk from the joint math meetings that inspired this, and the presenter, whose name I'm just forgetting, unfortunately. The presenter shows a super complicated graph, and then one that it's the same as, and it's actually really neat to see it. So, all right, good work today, guys.